Hello, everybody, and welcome back to our fifth question in Part A. We've got this one and then question 6 left to go in Part A on our CIMC Canadian Intermediate paper. Positive integers A, B, and C satisfy the equation 31 over 72 is A over 8 plus B over 9 minus C. What's the smallest possible value of B? Oh, now that is interesting. Okay, smallest possible value of B. I think the fractions there are just sort of there to scare me, I guess, a little bit. Okay, let's just multiply everything by 72. You'll get 31 over here. 72 with divided by 8 would leave 9, so we'll get 9 A's, 8 B's, and minus 72 C's. Okay, so this is nicer. It's less fraction-y, I guess. Now we want to make B as small as possible. Okay, so did they say they have to be positive integers? Yeah, they're positive integers. So I can't have B be 0, but maybe B is 1. So then this would be 8. So 31 is 9A plus 8 minus 72C. Can I find positive integers A and B, or A and C, that make this work? So if I subtract 8 from both sides, I'll be left with what? 23 is 9A minus 72C. And now the question is, can I find A and C that make this work? We can play around with it. We can think about it for a moment, but something's really sort of begging to be done. Let's take out a factor of 9. This over here, A and C are positive integers, so whatever this is over here is a multiple of 9. 23 is not a multiple of 9. So there's no way I can pick A and C that make this work. So whatever B is, it's got to make 31 minus 8B a multiple of 9, and that should be the only requirement. So let's rearrange this equation really to highlight this fact. Okay. So we've got to get a multiple of 9. Well, let's make a nice little chart of values. So B, what 8B is, what 31 minus 8B is, and then we'll say multiple of 9. Okay, so that's going to be our desire. And yeah, okay, so 1, we know that's not going to work, but 2, 3, 4, 5, 6, 7, 8 shouldn't need to go past 9 at all. We should well be able to find our answer before then. 72, 64, 8, this was 23, 16, 24, 56, 48, 40, 32. Just keep subtracting 8 over here, so we'll get 15 and 7 and minus 1. These negative numbers are allowed. It's A, B, and C that have to be positive. Minus 9, minus 17, minus 25, minus 33, minus 41. Okay, now we want the smallest value of B, so we're going to start looking top to bottom. Multiple of 9, no, 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 yes. So I would like B to be 5, but let's just double check, can I actually get an A and a C that work? So if B is 5, none of the other smaller positive integers would work. 31 minus 8B is negative 9. Can I make that 9 times A minus C? So then we'd have A minus 8C needs to be negative 1. I don't know, let's C be 1. And bring it over to the other side. A could be 7. So let A be 7, B be 5, and C be 1, and that works fine. So B equals 5 is the smallest possible value. There we go. So that's question A5 all squared away. We've got one more question to go in part A, and if you had some trouble with it, and A6 tends to be a harder question, so many of you out there might have, feel free to join me as we go through A6 next time. Goodbye.